Morning. Myself, Dr. M.S.M. Kamil, Assistant Professor from the Department of Chemistry, C. Abdul Hakeem College, Melvisharam. My today's topic is nuclear chemistry. What is radioactivity? An element or mineral which emits radiation spontaneously is said to be radioactive, and the phenomenon is called radioactivity. Radioactivity is a nuclear property and is independent of temperature and other physical conditions. Radioactive series, the collection of elements that are formed from a single radioactive element, that is from the parent element, by the successive emission of alpha and beta particles, is known as radioactive series. Various rays from radioactive materials that are emitted are alpha rays, beta rays, and gamma rays. Here, the alpha particle emission, beta particle emission, and gamma particle emission are represented pictorially. What is the difference between the alpha rays, beta rays, and gamma rays? The alpha rays, they are positively charged particles. We have to understand that alpha rays are positively charged particles, whereas beta rays, they are negatively charged particles. The gamma rays are nothing but the electromagnetic radiation like the visible light or X-ray. They are alpha rays, they are deflected by electric and magnetic field. Beta rays, they are also deflected by the electric and magnetic field. Gamma rays, they are remain undeflected by electric and magnetic field. Affects photographic plates and cause fluorescence. It also, beta rays also, it affects the photographic plates and cause fluorescence. Gamma rays, it also affects photographic plates and cause fluorescence. Alpha rays, they produce strongest ionization. Beta rays, they produce less ionization than alpha particles, or we can say alpha rays. Gamma rays produce little or no ionization. The penetrating power. The alpha rays, they have the least penetrating power. Beta rays can penetrate through cloths, skin, paper, stopped by a sheet of aluminum. Most penetrating power is for gamma rays. Biggest mass, alpha rays, they have the biggest mass and charge. Beta rays, they have the smaller mass and charge, and the smallest, that is mass, and it is no charge, neutral particle. Gamma rays can travel up to 2 to 4 centimeter, can travel up to, beta rays can travel up to 2 to 3 meter, and gamma rays, they can travel up to 500 meter. +2 charge for gamma rays, -1 negative charge value, and it has no charge. Gamma rays, they have no charge. Here it is shown pictorially the penetrating power of alpha rays, beta rays, and gamma rays. The alpha rays, it can penetrate only through the paper, whereas the beta rays, it can penetrate through the paper, it can penetrate through the aluminum sheet or aluminum foil. Gamma rays, it can easily penetrate through the paper, aluminum foil or aluminum sheet, and a block of lead. So it clearly shows that the gamma rays has the highest penetrating power among alpha rays, beta rays, and gamma rays. The three types of radiation so far we have discussed, but we are discussing here by using this table. Okay, here first the nature. What is the nature of the alpha particle? It is actually a helium nuclei. Alpha rays are helium nuclei. It has 2 protons and 2 neutrons. About the nature of beta, it is an electron. About the gamma, it is an electromagnetic wave. The charge on alpha particle is +2, the charge on beta particle is -1, the charge on the gamma rays or gamma particles, it is 0, that is no neutral, they are neutral, they carry no charge. Mass, the alpha rays, they are relatively large. Beta rays or beta particles they are very small. Their mass are very small, and gamma rays, they have no mass. Speed, since alpha particles are heavier, their speed is slow. The speed of the beta particles is fast, but very interestingly, the gamma particles, they travel with the speed of light. Ionizing effect, it has the alpha rays, they have a strong ionizing effect, and followed by beta rays and gamma rays. Most dangerous when source is inside the body. When source is outside the body, the beta rays are more dangerous when the source is outside the body. Gamma rays when the source is outside the body. The similarities and what are the changes that are taking place during an emission of an alpha, beta, and gamma particles. The first type, the decay type, alpha decay, where we can also say alpha particle emission or alpha ray emission or alpha decay. It gives off 2 protons. Whenever an alpha decay takes place, it gives off 2 protons, 2 neutrons. The alpha particle is equal to helium nuclei. What is the nuclear changes that are taking place? Mass number decreases by 4, atomic number decreases by 2. The radiation penetration and the large particle easily stopped by cloth, and it has very low risk to the cells, to the human cells. Beta particle. Actually, the beta particle, the beta decay is nothing but an electron. It is an electron emission. What happens to the atomic number? The atomic number increases by 1. The mass number stays the same. Even after beta emission, there will be no change in the mass number. These beta particles are high energy particles, pass more easily through matter, need metal sheets to stop it, moderate risk to the human cells. Gamma rays. A gamma ray is a high energy, in the form of electromagnetic radiation. And it is very interesting to note that there is no change in mass number and atomic number when a gamma decay takes place. Gamma rays, they have high penetrating ability. They are very dangerous to the living cells. To stop the gamma rays, thick blocks or lead or concrete are needed. To understand this alpha particle and beta particle emission, we have to know the atomic symbol. The X, it is a general representation. The X represents the element. The symbol X represents the element. The A in the superscript, it indicates the mass number, which is nothing but the number of protons and the number of neutrons. The Z in the subscript, it indicates the atomic number, which indicates the number of protons. Here once again we have shown the A, it is a mass number, number of protons and number of neutrons. The Z, the atomic number, which indicates the number of protons or number of electrons. Number of neutrons is equal to mass number minus atomic number. Okay. The radioactive disintegration series. The series showing the successive stages of the radioactive disintegration process together with the radioactive elements formed in the process till a final stable element forms is known as radioactive disintegration series. 3 such natural disintegration series and 1 artificial radioactive disintegration series have been identified. We know that an alpha particle is a helium nucleus of mass number 4, that is, mass number 4 indicates that there are 2 protons and 2 neutrons are there. The emission of an alpha particle from a radioactive element causes the mass number to decrease by 4. Further, since 2 protons have been lost, the atomic number falls by 2. The daughter element therefore moves 2 places to the left of the periodic table. The second one is the beta particle. The beta particle, actually it is an electron. It is emitted from the nucleus, but there are no electrons in the nucleus. Its origin is uncertain. It is postulated that a neutron changes into a proton and an electron. Therefore, the number of protons in the nucleus increases by 1. In other words, the positive charge on the nucleus increases by 1 unit, that is 1 group towards the right of the periodic table. Here the periodic table is shown here to understand the radioactive disintegration series. First one is the uranium series. It is also known as 4n+2 series. The uranium series, why it is called 4n+ series? If you divide by 4 and the remainder is 2, so if you divided it by 4, 238 divided by 4, you will be getting, the remainder will be 2, so it is called 4n+2 series. Uranium 238, it emits an alpha particle. Definitely what is going to be happen there? Definitely the atomic number decreases by 2. That is 92 minus 2 is equal to 90. And at the same time, the mass number decreases by 4. 238 minus 4, it is 234. You see here what happens. What happens to that one? The thorium is formed. You see here in the periodic table, in the bottom, in the actinide series, you can see the uranium, that is 92. Its atomic number is 92. we have discussed so far that whenever an alpha particle is emitted, the daughter element formed will move two places to the left. So 92 minus 2, that is 90, that is thorium 90. That's why we have written here 90 to 34, because the mass number decreases by 4, 238 minus 4. Now the beta particle. Whenever a beta particle is emitted, what happens to the atomic number? The atomic number increases by 1. So P. Now here we can see the 91 promethium, proactinium, not promethium, it is proactinium 91. Since beta particle is emitted, there is no change in the mass number. Similarly, it goes on. Proactinium, it emits a beta particle and it forms uranium 234, and uranium 234, it emits an alpha particle, it forms thorium 230. Like this it goes on, and the end of the uranium series is the stable isotope of lead. So this is the first radioactive series that we have discussed. We'll continue with another video. 16 का दिखा था ना, 16 minutes